Hello dear students, welcome to another video of engineering mechanics presented by Video Lectures for Engineering Students. In this lecture, we will be seeing a problem involving the power generated by a moving body. Okay, so we know what is power. Power is equal to the force acting on a body to move it multiplied by the velocity at which the body is moving with the result of the action of the force. Okay, so power is equal to force into velocity. Force into velocity. So in the question we are going to discuss, you can see here a train of weight 2000 kilonewton, that is 2000 into 1000 newton, moves down a slope of 1 in 150 at 18 km per hour, and the engine develops a power of 35 kilowatts. So the engine develops a power of 35 kilowatts. If the train is pulled up the same speed, what power will be required to pull the train? Okay, so read the question again. A train of weight 2000 kilonewton moves down a slope of 1 in 150 at 18 km per hour with the help of an engine which is developing a power of 35 kilowatts. So if the train is, in this case the train is moving down, and in the next case, if the train is pulled up at the same speed, what power will be required to pull the train up the plane? Okay, so that is what we have to find out. The power needed to be developed by the same engine to move or to pull the train with the velocity of 18 km per hour up the same plane in the opposite direction. Okay, so we will solve this like this. You just see this. The weight W is equal to 2000 kilonewton, and it will be 2000 into 1000 newtons. The slope of the plane, inclined plane, is given as 1 in 150. What do you mean by 1 in 150? That means for 150 meters of horizontal distance, 1 vertical distance. For 150 meters of horizontal distance, 1 vertical. That is 1 vertical out of 150 horizontal. Say units. If it is kilometers, 1 kilometer vertical distance divided by 150 kilometers. If it is in meters, 1 meter divided by 150 meters, or 1 in 150 horizontal. Okay, right. Then, as we know, the slope is given as 1 in 150. This angle, so this is the slope on which the train is moving up and down. In the first case it is moving down, and in the second case it is moving up. Okay, so the train is moving on an incline of 1 in 150. That is, this angle will be very small. If you consider tan theta is equal to 1 by 150. So as this angle is very small, that is, we know 1 by 150 will be a very small value. Therefore, tan inverse 1 by 150 will be a very small value. So sin theta in for very small angle of value of theta will equal to tan theta, or tan theta is equal to sin theta. Therefore, in this case, sin theta is equal to 1 by 150, where 1 by 150 is equal to tan theta. Then speed of the train is given as 18 km per hour. Okay, so we need to convert this into meter per second. For that, we have to multiply it by 1000 by 60 by 60, 60 into 60. So this 18 is kilometer is being converted into meter, and the hour is converted into seconds. That is 60 minutes into 60 seconds. So it will be, finally, when you simplify this, you will get 5 meter per second as the velocity in meter per second. Then the power developed by the engine, it is given in the question. Power developed by the engine is 35 kilowatts. So that is equal to 35 into 1000 watts. That is equal to 35,000 watts. Now let us consider the first case. That is, the train is moving down the plane. Train is moving down the plane. Okay. So when the train is moving down, you can see the direction of motion will be in this way. Direction of motion will be in this way. And what will be the forces causing this motion? The forces causing the motion will be W sine theta. W sine theta. From where this W sine theta comes? That is, it is a component of W, weight of the train, parallel to the inclined plane. And the component which is perpendicular to the plane is W cos theta, and the component parallel to the plane is W sin theta, and the component perpendicular to the plane is W cos theta. Okay. Is it clear? Because the weight W is acting vertically downwards, which is at an angle of the plane is at an angle of theta. The W is acting vertically downwards, therefore it is at some angle with the inclined plane. Therefore, we have to resolve all the forces which is at an angle to this plane. So the only force which is at an angle with the plane is W. Okay, so that is being resolved into two components. We know that the component which is parallel to the plane will be W sin theta, and perpendicular to the plane will be W cos theta. Okay. So the forces which is acting in the downward direction parallel to the plane is, the first one is W sin theta, the second one is P. What is P? P is the force generated or applied by the engine on the train to pull the train down the plane at a speed of 18 km per hour or 5 meter per second velocity. Okay, so P is the force required to produce 5 meter per second velocity. Okay, so these two forces are in the downward direction, and of course we know there will be some frictional resistance. Nothing is mentioned about the frictional resistance. We can just put F as the frictional resistance, and as the train is moving with the uniform velocity or constant velocity, there is no acceleration. That means there is no net force acting on the train. No net force acting on the train. Anyway, to move the train downwards, the engine has to apply a force of P in this direction, and you can see here. Okay, so in the figure, W sin theta is in the direction of motion, force of friction in the opposite direction of motion, force P exerted by the engine. Okay, in the direction of motion, by the engine in the direction of motion. Now, the net force acting on the engine in the direction of motion. What will be the net force acting on in the direction of motion? Net force acting on the engine or net force on the train will be, you can see, in the direction of motion. Direction of motion is downwards, therefore parallel to the direction P, W sin theta and F are in the same direction, and parallel direction, and F is in the opposite direction of motion. Okay, so normally we will be considering or assuming that the forces which is in the same direction of motion as positive, and those are opposite as negative. Okay, so the equation will be like this: W sin theta minus F plus P, because W sin theta is in the same direction, P is in the same direction, F is in the opposite direction. So W sin theta plus P minus F, and that is equal to 2000 into 1000 into 150 minus F plus P. That will be, you will get it as 13,333.3 minus F plus P. That is the net force acting parallel to the plane. Then the power developed by the engine. We know the equation: power is equal to force into velocity. Power is equal to force into velocity. Now, to generate a power of 35 kilowatts or 35,000 watts, the engine has to apply a force of P, and we know here P into 5 is equal to 35,000. Is it not? 35 kilowatts. P is the force applied, 5 is the velocity, constant velocity. So P into 5 is equal to 35,000, and from this you can easily find out P. P is equal to 7,000 Newton. P is equal to 7,000 Newton. Then, so we can substitute the values in this here. That is, then the net force will be 13,333.3 minus F plus 7,000. That is the net force, sigma F. Say. Then, but we know that the net force is 0. We have already discussed about that, because as there is no acceleration for the engine, isn't it? Because it is moving with a constant velocity of 5 meters per second, there is no acceleration. Therefore, if there is no acceleration according to Newton's second law of motion, there should not be any net force acting in the direction of motion. So here the net force acting is 0. You can see this. The net force acting is 0. So we can write 13,333.3 minus F plus 7,000 equal to 0. Equal to 0. Or you can write F is equal to 20,333 Newton. So that will be the total frictional resistance acting on the train. That is, F is equal to 20,333.3 Newton. Okay. Then let us consider the second case. Now in the second case, the train is moving up the plane, with the same velocity. Isn't it? If the train is pulled up the same speed, what power will be required to pull the train? So now, in this case, the train is moving up the plane, the same velocity, same plane, everything is same except the direction of motion is in the upward direction. Okay. Now, what are the forces acting on the train? The first one is the force P applied parallel to the plane up in the upward direction. Then definitely, as the train is moving in the upward direction, the force of friction should be in the downward direction. Force of friction is in the downward direction. Okay. Then weight is there. Same weight is there. 2000 kilonewton is there, and its components are W sin theta parallel to the plane, W cos theta perpendicular to the plane. Then this is theta. Inclination is same, 1 in 150. Okay. Now see. Let us see. As the plane is same and hence frictional force will be same, isn't it? As the plane is same, the frictional resistance will be same. That is same as F we found out already. That is F is equal to 20.333 kilonewton or 20,333.3 Newton. That will be the frictional resistance. So let P star equal to force exerted by engine while moving up. So in this case, the force P is the force is assumed as P star. P star. So that is equal to force exerted by the engine while moving up. So net force in the direction of motion. So as in the previous case, the net force in the direction of motion or parallel to the plane, it is, what will be the net force? So P is considered as positive because it is in the same direction of motion. W sin theta will be minus, friction will be minus or negative. Okay, so what will be the net force acting in the same direction of motion or parallel to the plane? That will be P star minus W sin theta minus F. P star minus W sin theta minus F. That is what is written here. That is P star minus W sin theta minus F. When we substitute the values, P star minus 2000 into 1000 into 1 by 150 minus F is same. Is not? F is same. 1 by 150 minus 20,333.3. So here we can easily find out P or P star. By simplifying, you will get P star minus 33666 or 33,666.6. Again, the train is, as in the previous case, the train is moving with the constant speed. The plane is moving with the same speed, and hence acceleration is 0. You can see here, acceleration is 0. So that means the net force will also be 0, because if there is no acceleration, there should not be any net force in that direction according to Newton's second law. Okay, so P star minus 33,666.6 equal to 0, or P star you will get this value, that is 33,666.6 Newton. So once we get the force developed, as the velocity's value is given, you can directly multiply the force and the velocity, you will get the power generated. That is, power developed by the engine is equal to force exerted by the engine into speed or velocity. So P star into V, that is equal to 33,666.6 into 5, that is equal to 168,333, or that much watts, or it is equal to 168.333 kilowatts. So that is the answer. Okay.